Okay, make sure to put your date at the top. Here, let's do this. Got the date, and tonight's topic is on the distance formula. Okay, so when we have something like this and we need to find the distance between A and B, this can be quite simple because we can just count units across. So for this one, we can say it's 1, 2, 3, 4, 5, 6. So the distance, which is D, equals 6 units. And then if I knew that these were centimeters for sure, I might say 6 centimeters or whatever. The problem comes when we have a long distance to find, such as trying to find a diagonal distance. If you're trying to find a diagonal distance, well, you can't just count squares because they're not going across at even rates. So that's when we need what's called the distance formula. So the distance formula is D equals the square root of x2 minus x1 squared plus y2 minus y1. Okay, so if I'm looking at this problem right here, you're going to need a calculator to solve these. If you don't have a calculator, you could just leave them in square root form. So here, we'll just label this x1, y1, x2, y2. And so we're just going to plug them into the formula given. So we'll put D equals square root x2, which is 5, minus x1, which is 3, and then we square that, plus y2, which is 4, minus y1, which is 1, and then we square it. So then let's start doing some math. 5 minus 3 is 2, so that's going to be 2 squared, plus 4 minus 1 is going to be 3 squared, so that's going to give me 4 plus 9. So this is the square root, so we're going to have the square root of 13. And then if you have your calculator, you're going to turn that on. And our square root sign is opposite the x squared, because these are actually inverses. They undo each other. So we'll just go second square root, and then we just put in 13 here, and enter, and it's about 3.6 units. So then we might just leave it like this, or we could say D equals 3.6 units. All right, so that's how you find distance of diagonal lines. So let's look at another example. So let's look at number 4 here, since they left it in square root. So my first thing I need to do is figure out what these points are. So this is negative 3, 1, and then this is 2, 3. Now if you draw the diagonal, we have no idea what that distance is. So that's where the distance formula is needed. So let's do this. Okay. So I'm going to use my distance formula. So we have the square root, and then let's see, let's make this one x1, y1, and it really doesn't matter which order you do this. I could make this x1, y1, x2, y2, it doesn't matter as long as you identify one as one of them. Okay, so I'm supposed to do y2 minus y1, so that's going to be 2 minus negative 3, whole thing squared, plus y2 minus y1, so that's 3 minus negative 1 squared. So don't forget to change your signs here. Change it to negatives. So this is going to become 5 squared plus 4 squared, and this is still all under the square root sign. So that's going to give me 25 plus 16, or the square root of 31. Is it 31? I'm sorry, 41. So obviously that would be C. Okay, so you just got to get good at plugging it into the distance formula equation. So let's do a couple of couple of examples for you. So for the first question, let's do number 1. And find the distance between ST and choose A, B, C, or D. Then I'd like you to go ahead and move on to number 2. Should be the distance point between Q and R. Should be a nice whole answer for those. And then let's try, I don't know, should we try 5? Let's try 5. So we'll do this one right here. Let's do number 5. So we'll do 1, 3, and then this last one, 5. And we'll see how you do tomorrow.